Okay, so here is a question which one of the students actually had a doubt about. He was unable to solve this and he just requested me to solve it for him. You can see this is how it has been given in the examinations, and the diagram is not very clear. This wall over here is vertical and this one here is inclined. The slope has given the vertical length being 3 and horizontal being 4, and we are supposed to find this angle theta at which this bar over here it's going to remain in equilibrium. So he has not mentioned anything about friction, so friction has got to be neglected. We just have to consider the walls to be very, very smooth, and only normal reactions we got to consider at these two walls. Okay, so here is the diagram. I have redrawn it exactly, and you can see that a force of 200 Newton is acting over here and a force of 100 Newton is acting here. The distances have been given, the slope is given, and we have to find this angle theta. Okay, so we have to replace these contact points with their equivalent forces when we have to draw the free body diagram. We have to draw the free body diagram of this bar that is resting here, and this is how we will get the normal reactions on it. So let me just go ahead and call this force here, this reaction, as P, and this reaction here as Q. Okay, so now we will have to one by one apply the equations of equilibrium. Equations of equilibrium we'll have to apply, and we all know that there are exactly 3 equations of equilibrium. One is the sum of all the horizontal components equal to 0, sum of all vertical components equal to 0, and sum of moment taken about any point. We can take either this point or that point, about any point when the sum of moments due to all the forces is taken, it's equal to 0. So one by one we'll have to apply this. So let's take up the first one, sum of all the horizontal forces. We have here a horizontal force Q, the reaction. It's acting on the right side, so it's going to be taken as positive. This force here is vertical, so it will not have any effect in the horizontal direction. We have here the force of minus 100, minus because it's acting on the left side, and then we'll have to take a component of this force here. So in order to find the horizontal component of this reaction P, we'll have to first find out its angle with either the vertical or the horizontal. So in this case, we'll be easily able to find its angle with the vertical, and that angle will be same as this angle here. So this angle here, let's call it as alpha, and we know tan of alpha will be opposite by adjacent, so this formula we'll have to use, and alpha we will get it as tan inverse of 3 by 4. So let me take the calculator over here. I'll have to use the scientific calculator. 3 divided by 4, and the answer of this we'll have to take, so this I'll have to take tan inverse. So I'm getting 36.87 degrees as the angle. So the same angle alpha will appear over here. Okay, so now let's go ahead and take the horizontal component of the reaction P, and that will be acting on the left side, and its component will be P sine alpha. So minus P sine alpha. This is going to be the component. So this total has got to be equal to 0, and now we know the value of alpha. Alpha value is known over here. If we substitute, we will get 2 unknowns here, but that is still not solvable. We will need another equation. So let's just give it an equation number and proceed to for the next equation. Now let's take all the vertical components of the forces. These two forces, the Q and 100 newtons, they are horizontal. They will not have any component in vertical direction. We'll just have to take minus 200 newtons, which is acting downwards, hence negative, and we'll have to take the component of the force, the reaction P. That of course is acting upwards, and hence it's going to be positive. Now the vertical component is going to be P cos alpha, and this total has to be equal to 0. Now if you notice here, alpha value is known, and here the only unknown we have is P. So using this equation we can just go ahead and find the value of P. So let's do that. Minus 200 sent to the other side, it becomes 200, and cos alpha will go down with the denominator. The angle is known, that is 36.87. so let's solve it. So that's 200 divided by 36.87 cos of this angle, So the answer we're getting is 250. So 250 newtons is the answer we got for P. Now we have ended up using the two equations of equilibrium, the vertical and the horizontal components. Now we have to go for moment. So now moment we can take about any of the points. We can just go ahead to choose either about A point or about the B point. Now let's go ahead and choose about B point, because this will eliminate completely this particular reaction, which is inclined at various different angles, and it's going to be very difficult for us to find that. So let's go ahead and take the moment about B. So taking the moment about B, we'll have to take all the components. So first force here is Q. Now we'll have to take the distance, right? So now about the point B, we'll have to find the perpendicular distance, and this distance here is going to be the perpendicular distance for the point B for this particular force Q. Now the total distance of this rod is you can see it's coming out to be 4 meters, and we want only the vertical component, this angle being theta. So what we have here is going to be 4 times sine theta, 4 times sine theta. So that will be the perpendicular distance, and let's go ahead and apply it here. So Q is the force, and 4 sine theta is the perpendicular distance, and since it's rotating it in clockwise direction, we'll just have to take it as positive. Let's take the next force, that's 200, and for this the perpendicular distance for this it's going to be on this side like this, and once again this angle is going to be theta. It's going to be alternate interior angles for this, so it's going to be theta, and we have to find this particular distance. So that's going to be 2 times of cos theta, 2 times of cos theta. Let's go ahead and take that here, 2 times cos theta, and since it's rotating in anti-clockwise direction, trying to rotate the bar in anti-clockwise direction, we're going to take it as minus. So next we'll have to take this force here, 100 newtons, and okay, let's take it 100 newtons, and we'll have to find out the perpendicular distance for this. Once again, the perpendicular distance here is going to be this value. Hypotenuse, you can see it's 1, and this angle being theta, this is going to be 1 times sine theta. So let's put it over here, 1 sine theta, and this particular force is again trying to rotate the bar in anti-clockwise direction, hence we got to take it as negative. So this force, of course, it's passing through B, so it will not have any moment, and this is the equation we are getting. We can see that there are still 2 unknowns in this particular equation. So if we know the value of Q, you can easily find out the value of theta. So Q value we have not found as of now, but you can see that if we substitute the value of P in equation number 1, then we can find it. Fine. So let's go ahead and take that. So let's substitute the value of P in equation 1. Let's substitute P in equation 1. So let's take that equation 1. So here it is. I have taken the equation number 1 here, and I just have to substitute the value of P into this. P is 250, and alpha value is known, 36.87. So let's substitute and find the value of Q. So Q value is going to be 100. When sent to the other side, it becomes positive 100, plus P, that's 250, times the sine of alpha angle being 36.87, and sine. So this gives me 250 again. Okay, so now we got both the value of P as well as Q as 250 newtons. Let's substitute the value of Q here in this equation, and we will be able to find the value of theta. So here Q value is 250 times 4, that is sine theta. Cos value, let's send it to the other side, and 100 sine theta, of course, it's going to be remaining here. That value, 200 into 2 cos theta, will become positive and sent to the other side. So now what we get here is, so this is the value we get. We get 900 here on this side, 900 times sine of theta, and on the other side we have 400 times cos of theta. Now taking cos of theta on this side, we get sin theta by cos of theta, that equals 400 by 900, and that is of course tan of theta. So tan of theta is equal to 4/9. So just by going ahead and doing the calculations, we will be able to get it. So 4/9, this is the value, and we got to take inverse tan of this. So we're getting that angle as 23.96. So the angle theta is 23.96. Fine. So hope you have understood this particular problem. If you want more problems of this type, let me know in the comment section below. Of course, subscribe to the channel and share these questions with all your friends, and hope you will be solving more and more questions in the coming time. Thank you for now. Goodbye.